Maths Jedi. Sorry I haven't been with you for a few weeks. It's been really busy. Today I'm going to do a maths revision video on functions. If you're new to this channel, please do subscribe by clicking the subscribe button below, or give me some likes as well. That'd be really appreciated a ton. But today we're just going to do functions. The purpose of this video is just to give you about half an hour or so. This one will be about half an hour or so, just to go through some key topics again. All of the things I'll do will be Edexcel exam questions, and primarily these videos are for those revising for GCSE mathematics exams for the summer. So without further ado, let's just have a look at this first question. You can see today we've got functions lined up ahead of us. This is talking about two functions, f of x being 3x squared and g of x being 1 over x minus 2. Now, functions are quite a tricky little topic. You do need to make sure that you know how functions operate really. Primarily when you're doing functions, you always do everything opposite to what you expect. So this one is asking for g of f of 4. So g of f of 4. You really do opposite. Best way to do this is to do it from right to left. So if we imagine covering up the g and looking at just what's on the right hand side, the f of 4 bit, we're going to do f of 4 first. So we do the bit on the right hand side first. So f of 4. Wherever I see an x in this expression, I'm then going to think about that being a 4. And using the rules of BIDMAS, I'm going to do 4 squared, which is 16, and then 16 times 3, which is 48. Now, what do we do with that 48? Well, we haven't yet dealt with the bit that we covered up, the g bit. So what we're going to do is we're going to do g of this 48 now. We're going to do g of 48, because 48 was the output for f of 4. We're now going to put that 48 into g of x. So we're going to go ahead and do that real quick. So g of x, g of 48 equals 1 over 48 minus 2. So again, what we're doing is wherever we see an x, we're putting 48. And that will give us 1 over 46. So the answer here is 1 over 46. It does ask for the answer to fraction, so that should make complete sense. Right, question 2. Again, all of these exam questions, unless I tell you otherwise, they should all be exam questions. They're all coming from past papers or questions that are set up as practice papers. So you should have seen these with your teacher, or you might be about to do these with your teacher soon. This question here, again, another functions question. This time we're doing some very straightforward questions. Similarly, f of minus 5. So again, wherever I see an x here, this is x squared. Hope you can see that okay. I'm going to do, where I see an x, I'm going to put minus 5. So just 2 over minus 5 squared. Okay, I tend to use brackets just to help me with negative numbers, just so I don't get muddled. And this will be 2 over 25. Why is it positive 25? Because minus 5 times minus 5, two negatives do make a positive. So 2 over 25. And again, reading it right to left, we're going to do g of 1 first. So wherever I see an x, I'm going to imagine that's just 1. So that's just 4. And then I'm going to do f of that, f of 4 now. So again, 2 over 4 squared. This is f of 4. And 2 over 4 squared. And again, that's 2 over 16, which is an 1/8. Okay, so again, very straightforward. Not a problem. You might also be asked questions about inverses, and this question is talking about an inverse. So the function here is given as 4x minus 1. We're being asked to find the inverse function. So to find inverse functions, you go through some definitive steps. First of all, you make y equal to 4x minus 1. So y equal to 4x minus 1. So this function, in other words, you make that equal to y. What you then do is rearrange the function to make x the subject to the formula. So that's quite simple. You just will do y plus 1 divided by 4 equals x. Okay, I've skipped a couple of stages there, but hopefully you can see how I've done that. So I've added the 1 divided by 4. That makes x the subject to the formula. What you then do is to create the inverse function, you're just going to substitute where you see a y here, you're going to write an x instead. And so that becomes your inverse function. So it's x plus 1 over 4. So simply all you do is just substitute where you see a y, you put an x instead, and just write down the function x plus 1 over 4. That's what you got here. That's what the inverse function is. Now this one says the function g is such that g of x equals some constant times x squared. So some constant times x squared. Given that f of g of 2 equals 12, again, right to left, g of 2 first, and then do the f of that, then work out the value of k. So we've got a couple of things that we've got to do here. So we're going to do g of 2 first. So g of 2 is going to be k times 2 squared. So that's 4k, in other words. So k times 2 squared, 4k. That's g of 2. The f of that function, remember we had f from up here, they are talking about the same f. We're going to do f of 4k now. So wherever I see an x in this expression, I'm going to put 4k from down here. So I'm going to create 4 lots of 4k and then minus 1. So 4 lots of 4k minus 1. We're being told in the question that that's 12 from over here. So I'm going to say that makes 16k minus 1 equals 12. And then we just have to solve for k to find the answer. So 12 plus 1 is 13. And then we're going to divide by 16 here. So 13 divided by 16 will be the answer for this. So it's quite straightforward to do it, but you do have to be really on your guard with regards to how you sort of work your way through these questions. The other thing you might be asked to do with functions is move them around, what we call transformations of functions. So this is a question about transformations of functions. It's a hidden transformation because they're asking you to write down coordinates and minimum points. So the first transformation you need to know is transformations up and down. And this is a transformation up or down because it's f of x plus a number. The other transformations you need to know are transformations left or right. That's when you've got x plus 3 inside of the brackets or x minus 3 inside of the brackets. But here it's just straightforward up or down. So given that this has a minimum of 3, minus 4, we're being asked to write down the coordinates of the minimum point when you move it up 3. It's just going to be 3 along, and then instead of minus 4, you're going to have minus 1. So 3 and then minus 1. Why is it minus 1? Because it's minus 4 and then plus that 3. So minus 4 plus that 3, you're going to have minus 1. So it's going to be somewhere up here. The last part of that question, I've missed the second one out. It's no longer on your syllabus, but this one definitely is. If you're asked about a question that says, can you write down the minimum point of f of minus x? That's going to be a mirror reflection in the y-axis. Basically, anything that's the value that you're getting for x equals 3 here will be the value that you get for x equals minus 3. So whereas we had 3, minus 4, for the graph of y equals f of minus x, the minimum is going to be minus 3 minus 4. It's just a mirror reflection of the graph. And if we were to draw the graph of f of minus x, it would just be a mirror reflection of this graph, something like that. Moving on, here's another question. Again, similar question to the previous one. This is talking about the graph y equals f of x drawn on the grid. Just let you see the question there. It says write down the coordinates of turning point. It's really quite straightforward. So for turning points, just be aware that you're looking at this highest point here. You're going to be reading off the graph here where that highest point is. So right the way up there. So it's going to be 1, and then obviously up here it's comma 4. So 1, 4 will be the turning point of the graph. Okay, so it's quite a straightforward question because it's a whole number. So these days they tend to make them a bit more obtuse, but this is quite straightforward. Then it says write down the roots of f of x equals 2. Now 2 is up here. That's the f of x axis effectively. So what it's asking for is it's asking you to think about if you were to draw a straight line going through 2 here and 2 there, it's asking for these 2 points where that curve cuts that straight line. So all you have to do is read off down and read those values off. Okay. The last section is asking you to write down f of 0.5, and again that's really quite simple. So here is 1, there is 0, there is 0.5. It's asking you to read off this value here. I'll just read all those points off for you. So here the value for 2 was, we have to be careful of scales here because it goes, so each little dot, each little square I can see is worth 0.1. So it's 0.1, 0.2, 0.3, 0.4, so minus 0.4. Okay, and over here we've got, so minus 0.4, just writing that down there, so I'll just show you that real quick. So minus 0.4, and then this one up here, again will be 2, and then 2.1, 2.2, 2.3, 2.4, 2.4 and a bit maybe, so 2.45 say, just to be super accurate. And these are the two roots. And then the f of 0.5 value, that's going to be up here. So I'm going to see what that is. So f of 0.5, that's going to be up here. So that's going to be 3.567, so 3.7. And I'll write that down here. So 3.7, just the value you got when you had 0.5 there. What other questions might you get? You might get questions about composite functions, and here is a question about composite functions. And again, these are relatively straightforward. You do have to take your time with them. The first one's very similar to some of the questions we've already done. So g of minus 4, you just put minus 4 in for this. So I won't worry about that one because we've done questions much like that earlier on. This one here is slightly more difficult. So this one is saying g of f of x show that g of f of x is this function. So again, we work right to left. So we're going to do f of x first. That's the 2x minus 3 from up here. And wherever I see an x in this expression, I'm going to put 2x minus 3. So if we were to think about that, it would be 2x minus 3 all squared plus 2. So 2x minus 3 all squared plus 2. We're going to square those brackets up. So 4x squared minus 12x plus 9 is what you'll get when you square those up. I'll let you do that at home, but that's what you will get. And then you've got the plus 2 on the end. That came from there. Plus 9 plus 2 is 11. So we're getting 4x squared minus 12x plus 11. Okay? Very straightforward, not a problem. And that's the proof they want. This one down here is asking you to show that the composite function f of g of x is the same as g of f of x. Well, we've got g of f of x. Now we need f of g of x. That means up in the f function here, wherever I see an x, I'm going to write this one now. So that will be 2 lots of x squared plus 2 minus 3. So what I've done there is I've just substituted for x there, I've written down the x squared plus 2 expression. So I've done it the other way around. Now I've got to show it's the same. So if I multiply out the brackets, I'm going to have 2x squared plus 4. And then I'm going to have minus 3. So that will give you 2x squared plus 1. And so then we need to make that function, as it's saying solve, we need to make this function 2x squared plus 1 equal to this function. So 2x squared plus 1 equals 4x squared minus 12x plus 11. That came from earlier. We're going to create ourselves a quadratic equation by getting everything on the same side. So I'm going to take away the 2x squared. So 2x squared minus 12x, that came from there, and then plus 11, and I'm going to get rid of this plus 1 here, so minus the 1 across, so plus 10 equals the 0. So that gives me a quadratic expression. Assuming that you can probably factorize this, I'm going to divide everything by 2 first, because I can see everything's a multiple of 2. So x squared minus 6x plus 5. And now I'm going to try and factorize this. This looks to me like it will factorize quite easily. So x minus 5 and x minus 1 will get you these things. We'll make this. So that gives you the answer x is 5 or 1. It's two answers because it's a quadratic. A couple more to do. This one here, so this is question 7 now we're on. And this is talking about, again, the first part, very similar to some of the questions we've done earlier, not too dissimilar at all. So asking you to work out your answers of fraction once you work out f of 5. So we're going to put 5 in wherever we see an x. So 1 over 5 plus 2, which is 7, and then 1 over 5 minus 3, which is 2. So it's a seventh plus a half. Effectively, this is now a fractions question. So we look for a common denominator, which in this case will be 14, and we're going to create ourselves the answer, which is 9 over 14. Don't think it goes any simpler than that. Write down a value of x for which f of x is not defined. That's a question that is pushing against the very boundaries of what the schema learning asks you to study. Basically, what it's asking for is when will these fractions be difficult for you to calculate? Now, you will not have known this, but dividing anything by 0 is impossible to do. So what you're looking for, what the question is looking for here, is the value where the bottom part of the fraction is going to be equal to 0. So in this case, it's going to be x equals minus 2 will be a problem, or x equals 3 will be a problem, because similarly that fraction can't be 1 over 0 either. So either of these two values will give you a situation where it's undefined. Lastly, it's asking you to do possible values of x once you give out the fact that f of x equals 4. So there's quite a lot to do here, which is why it's worth 5 marks. So you might see the marks in the bottom right hand corner. So we're going to put in 1 over x plus 2 plus 1 over x minus 3, and we're going to make that equal to 4. Now, using the rules of fractions, I'm going to create for myself two fractions with a common denominator. Just like a normal fractions problem, I'm going to multiply the bottoms together to find a denominator, and then what I do to the bottom, I do to the top. So that's how I've got this expression here. I'm going to leave the bottom alone for now, but I'm going to simplify the top. So x plus x is 2x, and then minus 3 plus 2 is minus 1. And then on the bottom, I'm going to leave this as two unmultiplied out brackets for now. That's equal to 4, of course, from up here. Now, once I've got this bit, I'm going to multiply everything on the right-hand side, the 4, by what's in the bottom here, the x plus 2x minus 3. So I've got 2x minus 1 equals 4 lots of x plus 2, x minus 3. And we've got, again, another quadratic that we can multiply out now. So let's just go ahead and do that. So I'm going to have first two terms x squared, outside terms minus 3x, inside terms plus 2x, last two terms minus 6. And that will all be multiplied by 4. And so I'll do that real quick. So I've got 4x squared minus 12x, minus 3x plus 2x. I should have simplified that first. So minus 3x plus 2x, we'll do that in a minute, but I should have simplified that first, cut my work down a bit. I'll do it next stage. So 2x minus 1 here from up there, of course. Then I'm going to simplify this now. So 4x squared, so minus 12x plus 8x is minus 4x. And then minus 24, that's still equal to 2x minus 1. Then I'm going to take everything together on the same side. So I'm going to have 4x squared minus 4x minus 2x is minus 6x. And then minus 24, and then add the 1. So minus 23 equals 0. So it's quite a, let's try to squeeze it in there. So 4x squared minus 6x minus 23 equals 0. Now, it's asking me to give the answer in the form p plus or minus q over r, which tells me that this is going to be a quadratic that I won't be able to factorize. It's probably one that I'm going to have to use the quadratic formula for. So you should remember the quadratic formula, but we're going to do that real quick. I'm going to write that down for you just so you've got it. You should remember it off by heart, of course, or try to at least. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. You do have to remember that if you can. So here the answers will be minus b, which is 6, plus or minus the square root of b squared, which is 36, minus 4ac, so minus 4 lots of ac, which is 4, and then minus 23, and then all over 2a, which is going to be 2 lots of 4, which is 8. Okay, we're still not quite there yet. I know I'm sort of filling up the space, but I'm trying to keep it as condensed as I can. Might shove over here a little bit. So we're going to simplify what's underneath that square root. So let's do that real quick. So 4 4s are 16, and we would have to probably do 16 times 23. We could do that longhand or shorthand. Either way, we're going to get to the answer, which is 368. So this is going to be 36 plus 368 divided by 8. So 4 4 16, 16 times 23, 368. Now we've got the 36 plus that, so that's 404. So that's going to be 6 plus or minus 404 divided by square root of 404, sorry, divided by 8. And I think that now will follow this particular methodology. This particular answer will follow that form. So something plus or minus the square root of something over something, that's what this is. So that for the time being will do. Okay, that's all for the this particular video on functions. I hope you'll tune back in for other videos to come. I'm going to do quite a few in the next few weeks, so hopefully you'll keep tuning in. I do hope that you will do well in your exams in the summer. Please do leave a like or subscribe to my channel, and you'll find new things coming up as many times as I can, and spread the word to your friends, and that will really help me out a ton. Thank you very much for watching, and I wish you all the very well best for the best rest of this week. Thanks. Bye-bye.